Hello, everybody. Hope you're doing well. My name is Kimmy. I am the VP of Operations for the Information Security Club, and thank you for tuning into today's speaker series. Before we begin, I'm going to add the QR code to the screen, and I believe the correct link to the attendance form, so we can move past this and get straight to the presentation. Okay, so joining us today is none other than Dr. Marina Gavrilova. Her talk will be on biometric security, privacy, and its ethics. If you have any questions during the presentation, feel free to drop in the comment section below. And without further ado, please welcome Dr. Gavrilova.
All right, perfect. Thank you so much, Kimi, for this introduction. Hello, everyone. Thank you for tuning in to this fairly informal presentation about biometric security, authentication, and in the new age of deep learning and AI and ChatGPT. So it will take me about roughly 40 minutes to go through my slides. Feel free to post comments in the comment section, and I will be able to address them or answer directly in the chat. So I've been professor at the University of Calgary since 2000, and for approximately 20 years, I lead the Biometric Technologies Lab, and we have collaborators all across the world, but within Canada, we work with high-tech giants, IBM, Google, Amazon, banks, as well as Canada Defense and Security on the problems of identifying potential risks to personal information, privacy, as well as break into the network system by password phishing or by social engineering, and uncovering information about perpetrators as well. So biometric comes very handy in this domain, in this framework, because it allows to authenticate person not by the usual password or not by the double authentication or two-way authentication that we all got used to, but also by something that we are. And biometric is, by definition, is something that we are, something that we as human bodies or we as human beings, in behavioral sense, possess. And just go to the next slide. And can be therefore identified by. So in this presentation, I'll quickly introduce you to biometric security research and my main domain, which is multimodal biometric or information fusion. And then I will open up about privacy consideration, ethics considerations that related to the use of deep learning within this framework. Here is just a number of different research domains that I have been involved over the years. Left to right in the lower row, we had hosted an international conference on cyber worlds, and a big part of it was cybersecurity, as well as virtual reality or online games, actors' identification by their behavior. So by the way, how they create avatars, how they decide how to interact with our avatars, what kind of characteristics and behavioral and visual properties the avatars have. Next, on the low row is ICCSA 2015, and it's a large scale conference. We hosted over 500 attendees from more than 50 countries across the globe. And this is about computational sciences conferences and deep learning and machine learning. The next one is Computer Graphics International that was taking place right here on campus, Roses Center, just before pandemic hit. And we had international experts on using computer graphics visualization and building virtual worlds in this conference as well. And on the right, you can see various journals: Journal of Digital Humans that I currently run as editor-in-chief, Journal of Transaction Computation Sciences with Sprint that I also run as editor-in-chief, and the book on multimodal biometrics that I co-authored with one of my PhD trainees, where we talked extensively about using Markov chain models and fuzzy logic to create more reliable ways to combine information coming from multiple experts or multiple sources. As a definition, biometric is a domain of research that studies physiological and behavioral human characteristics. One of the first mentioning in world literature of the biometrics actually comes in the novel Murder on the Mississippi by Mark Twain. And within this model, the perpetrator, the criminal, was identified by the palm prints left on the banks of the town, of the river Town, and after the rain, and when the fingerprints dried in the sand or on the clay along the river, that's how the murderer was identified. Since then, there was quite a few of other centers, mainly in London, as well as in France. The criminals were cataloged, and at that time there was no computer, so everything was done on perforated cards, and the system for cataloging was essentially by the name and then by the fingerprint, and then there's additional information about the height, the color of the hair, the color of the eyes, the length of the arms and legs. All this information was entered into biometric system to identify repeated criminals in England. On the slide, you can see different types of biometrics, and we usually separate them on three categories. The first one, the main category, is physiological. So this is something that we possess: face, retina, palm prints, iris, ears belong to this category. Behavioral category includes the gait, or the way how human walks, the voice, because it changes, and the speech changes depending on our mood, changes depending on our health state or anxiety or being calm, as well as some of the other characteristics. For instance, our preference for some images or our signature, because it's also very temporary and we can change it depending on our inclination or our mood. And then the final category is a new one. We introduced it in our biometric lab, and it's kind of took off and became quite known in the world. This is called online or social behavioral biometrics, and that includes human preferences for communication, friends, hobbies, preferences for images or music that one can like. And this is very powerful because it can allow, for instance, temporal pattern of our communication. Let's say on social media, how frequently we go on social media, and quite a few of you obviously have social media account, Twitter, LinkedIn. So all of the behavioral communication, set of friends, set of topics of interest within social media can uniquely identify the person. I was presenting the lecture at Fordham University in New York. It was Clavius Distinguished Lecture, and the Fordham University has long-standing collaboration with FBI as well as New York City Police Department. And they were very interested and engaged in ongoing collaboration on trying to identify online perpetrators by their behavioral patterns, their temporal profiles, which social media they use, how frequently they communicate, even if the content of communication sometimes is hidden. Obviously, there's large number of applications: access control, border surveillance. Every time if you went to travel internationally, anytime you travel internationally, you would cross the border and you would provide your biometrics. That includes your passport with ID, with your face profile, and then if you travel internationally, very frequently there will be fingerprint or a palm print get involved. Now, we do want to stop for a second and just mention that I cannot see anybody, but I'm pretty sure you're there and you're in the chat. So if you feel like it, feel free to post a note, post a comment, or ask any questions. Let me see if I'm connected. Okay, or ask any questions that you would like me to ask so that we can have some discussion. So brief research directions in our lab is we traditionally use large variety of classical machine learning for our classification identification, because the goal is we collect biometric sample from an individual or from data set, and we need to answer two questions. One is whether the person is the person whom they claim to be, or the other one is, if we don't know the identity, what is the likely identity in the data set. And for the data set, we usually can generate 5 top closest matches within the data set, or top 10 closest matches within the data set to the given sample, which biometric sample, which can be the face or the voice sample or the gait sample, or as we did more recently, just a set of 100 images that somebody likes, or 2 images that somebody likes. Then we came up with the notion of cancelable biometrics. And if your biometrics gets compromised, we create essentially a recoverable template, and the template can be rebuilt from the same face without sacrificing the original face data. And it can be therefore reused in case of breach in the data set. And there have been many breaches recently. I mean, I don't need to go and list all of them, but some of the largest one was MGM hotel breach in Las Vegas, where millions of customers' data, including credit card as well as biometrics and information on addresses and passports, were stolen and returned after handsome ransom that was paid by MGM to recover this data. Then we also work with the domain of visual knowledge discovery and social behavioral biometrics, trying to identify people by the behavioral patterns exhibited online. Here is an example of Chinook last winter festival representation of what we do in our lab. That was done during pandemic, and it was a time when you can see City of Calgary streets were quite empty. ATB Bank sponsored this particular exhibit, and it was co-created with the artist Vivian Smith. And you can see that us as human beings, us as a person, as a worker, as a student, can be identified by our social media profiles, can be identified by our emotions, gait, face, biometric data, and artificial intelligence, as well as matching or classification become some of the largest part of this process. We also contributed to United Nations Sustainable Goals within this lab by running a couple of cybersecurity journal special issues, and also informed the United Nations Development Program and Japanese government in the recent report on IT technology and legal digital identifiers, as well as Geneva Science and Diplomacy Anticipation Summit that looked to get an experts in AI, advising politicians, diplomats, and scientists, entrepreneurs about how advancement of AI-powered technologies will transform the future of global science. So they were looking at the ways to introduce anticipatory, responsible, inclusive, and sustainable AI-developed algorithms for biometrics. We have a pretty strong online presence. We just created a brand new Biometric Technologies website, but this is just one of the posters we used to advertise our research, to bring in new undergraduate students for research projects, and to collaborate with partners within the academia and industry. And example of project that we have, and I'm giving you very, very broad introduction to biometric security here, is, for instance, gate and voice biometric authentication for remote authentication within a meeting. And that was done with smart technologies here in Calgary, where the person just needs to come into the room, the gate will be captured, and the person ID will be established, and the proper access to the files, shared documents, and data set will be created. The next example is identification of fake online profiles, illegal social network activity done with the University of Purdue in USA. They have a large security center, and within the center we work on utilizing our concept of behavioral online social biometrics to identify if the account has been taken over and the activity and temporal patterns of connections, frequencies of communication, bandwidth of information being sent over network, if that has changed. If we can have access to the actual data provided, let's say on social platforms such as Twitter, for example, in this case, we can also use linguistics, telemetric, and temporal information from users' writing samples to identify whether account has been compromised or whether the activity is pretty common and normal and typical for the given user. And we also did a research project on intrusion detection through authorship disambiguation with a large cybersecurity center as well, with Purdue University. And within this framework, we actually tried to look at the over 1 million records of authors creating information for Wikipedia. And we're trying to find if some of them material created under different logins, under different names, belong to the same author. And we used the same idea of looking at linguistics, telemetric, and temporal patterns to identify which accounts of the users might come from the same user but under different aliases. There are also a large number of other projects that we're involved in that was drop-in center in Calgary, biometric check-in, and remote authentication of the physiological biomarkers on the body. There was work we did with kinesiology center looking at the performance of the athletes or performance of the soldiers under extreme conditions, high elevations, low temperatures, high temperatures. Looked at senior fall detection in smart homes using remote cameras, smart home observations. Person distress detection. When the person is standing in line in the supermarket, we can use remote observation of their body language to identify the emotions. It's one of the quite highly cited work that we did on trying to identify emotion of the person by just looking at the body language or body emotions. I see a first question in the chat, and I'm going to get straight to this question when I talk very soon about deepfake and using AI to generate fake information. So all of this research, as you correctly pointed out, was happening just before and prior to this explosion of AI that revolutionized the way how we as humans perform most of the activities, and definitely how we as researchers and how you as students as well approach your assignments, behave, create material, and learn as well. And with the new world in a new way, we have new challenges, and obviously authenticity of the data, ethical use of the data, introducing bias in AI architectures, or using the real world data, which already biased with biased prediction and biased outcomes, would augment this issue that we need to be aware of, the issue of what's the data that we're using, how accurate we are with the data, is the classification correct, if there's information that needs to be removed that should be private, left out from the training in deep learning models, and in general, with information that you see in front of you is generated by human or written by AI, or whether information you looked at, even as simple as a picture right in front of you right now, whether it's been created artificially or whether it's an actual product that exists in the real world. Example of, by the way, on this slide, it just shows a large number of different devices, smart devices, that connect together. Right now, they also, many of them use AI-powered assistant right now, and working with those devices allows us to explore new things, right? So we can look at, for instance, providing personalized services to somebody who has deficiency in communication or expression of their emotions, or providing new ways for online collaboration for people across the globe using haptic devices, such as even devices that replicate hug or touch right now, or you definitely can co-create in a special virtual space on our virtual platforms. Example of our gate authentication, where we look, the biometric research, just to give you background, goes deeply into numerical analysis, computational geometry, looking at the classical machine training, Markov chain predictions, DTW curves, and accuracy expectation of the classification algorithms. So all of this rooted in a deep math. So I'll just show you some more examples when we create virtual space and can look at the behavioral of avatars and their similarity, for instance, right here to online user behavior and their profiling. And authors and psychological traits recognition. Right here, examples, we have anonymous piece of writing. We can say whether it's William Shakespeare or Dr. Gavrilova or Kim Il-hyun or any of the other students created this text. So before we go to AI, I will talk a little bit about information fusion, because that was a foundation to what we do in our lab. We built multi-model biometric system, and that means that there's more than one expert who can tell what the identity is. So to tell my identity, for instance, from this video recording that you're creating right now or watching right now, you can take my voice, you can take my face, you can also look at the gestures that I make or movements of my body. And those three can be put together in a multi-model system, and the system will have a better chance of identifying me correctly because it has three of the different expert or metrics or evidence about my identity, instead of just looking at my still picture or still photograph or just hearing my voice recording. This is what we do. As part of the research, we build those architectures. Example in front of you is basic unimodal architecture. It starts with data caption model. We have a variety of different sensors. Essentially, I can give a 2-hour lecture on just types of sensors that you can use for face recognition or for capturing of the fingerprints, for voice recognition, or some of the other more advanced algorithms and methods to capture, for instance, my preferences for the images or music. Then we go through the processing module. Feature extraction is one of the key elements of this model. When we extract the features, we extract geometrical, textural, or visual features. For instance, for the fingerprint, we find the special points on our fingerprints. If you look at yours right now, you can see valleys and ridges. You can see more prominent lines, and you will see some of the lines they intersect. And when we look at those particular images, we can identify geometrical position as well as depth of those lines, and they'll become features of your fingerprints. For faces, we have a number of different features. Geometrical features will be symmetry, shape of the face, texture of the skin, color of the eyes, geometric relationship between all the elements on your face, brows, nose, and mouth. And when you look at large companies such as within Hollywood, such as, for instance, Disney or Pixar production, they will extract way more information from other faces in order to create photorealistic generation of the images, virtual images. ChatGPT does exactly the same, or generative AI does exactly the same by capturing the way how, let's say, your lips move when you talk, how the hair moves when somebody is running, when the artificial scenes for movies or animations being created, then this huge learning takes place, and that can be learning of based on photorealistic rendering, non-photorealistic rendering, ray tracing that will penetrate the skin, lighting. You can see I have behind me the window, the light comes from one side, falls on my hair. This all can be simulated using physical rendering, physical simulated modeling, or it can be simulated by using very, very advanced deep learning network generative AI algorithms that simply learn on a large number of samples and can recreate very similar to realistic images. You all know about text to images, image to text translations that's been very popular recently. And those approaches allow to give the textual description of the scene, and it will be reconstructed pretty accurately. So all of this based on feature extraction. Then those features, coming back to our biometric system architecture, will be stored in the database. When the new user comes, as you can see in the second row, green row, verification, the data will be captured, the user will provide their name, the processing module will extract the features, so it can be classical machine learning or deep learning algorithms that can be used to extract the features. And then it will be processed to the matching model. If the face will match, face provided to the system will match the face stored in the data set, that pass will be granted, the doors will be opened. All James Bond movies use this kind of technologies to describe biometric-based research and biometric-based security in high security vaults and banks or high security organizations. And then if the matching doesn't happen, it will fail. And then for identification, we don't, lowest row, we don't, yellow one, we don't have identity of the user, we go through exactly the same procedure, and person identity or chain-top identity matches will be identified. The contribution that we made to this process within the lab is, first of all, we created fuzzy logic non-binary system where the accuracy of the match can be not just pass and fail, 0, 1, or in the scale in the range from 0 to 1. So it's a fuzzy, can be 56%, 76% match. Then we created complexity by adding multiple modalities to the system. And then we all set that complexity to running matching algorithm based, let's say, on Bayesian networks or Markov chain models or probabilistic prediction of the identity of the person allows to come up with better set of candidates. So let me just see. My slides should be displaying the images, so we'll just move to this one. Unimodal framework. So within the unimodal framework, we have, and this is example for social media profiles, because I wanted to show that you can extract not only geometrical, physical, face-based features, but you can also extract, as in this particular case, features based on the writing, right? So right here, from the writing, from the training data, we can extract profile information, network information, communication information. Profile information can be name, address, IP address of the person. Network information can be type of information, type of the text that person writes. Communication, friends within the network, statistic features. And type of the communication can be, let's say, how frequently you text to some of your friends, how frequently you go on GitHub, how frequently you use some of the social media websites, and we can get some statistical features. All of these features will be stored in the training SBB features vector. And then when the new sample comes from the new user, let's say I have a text, right, on the tweet anonymously appearing, I can extract all the same features or those that I have and try to use similarity, various similarity measures. This goes back to classical Euclidean Minkowski Manhattan metrics. And then we compare the vectors, but we generate the final score of comparison, whether it's correct or incorrect. And within this final comparison score of the network, we can identify whether the two samples match or they don't match, and then come to final decision in terms of the access. And this is how multi-frame framework works. It's essentially we do exactly the same procedure, except for in this particular case, we're combining social behavioral biometrics with physiological biometrics. And the key module is right here. It's on the lower part within multimodal testing. It's right next to the final decision on the very right lower part of the slide. And this is called multimodal fusion. So we're combining information from multiple sources using various complicated mathematical multimodal fusion methods. Examples of social behavioral biometrics that we introduced can be given right here. So essentially, and I see this question, I still will come back to that, but misinformation, disinformation, fake news, deep fake images, rumors, and spam can be detected if we have ground truth. Even so, it's becoming increasingly difficult because right now we're going to have a constant push and pull, constant combat between the deep learning algorithms that can detect fake and deep learning algorithms can generate images as close to reality as possible. Then we have human aesthetics. So we can look at what aesthetical preferences somebody likes, so type of music, type of images, type of food. And then that can tell about identity. For online social media data, there's also opinion polling using demographics. And let's say some of the other financial factors can play a role in some of the AI-based decisions. For instance, banks use AI increasingly to decide on the loan. And big companies can use AI and will start using AI systems to sort through internship applications or job applications for all of you in order to select those that will continue on to the next stages of interview. Mental health and sentiment analysis as well. All of the part of social behavioral biometric, all of those can be used to identify the person and therefore also to secure your account. Because let's say if you have a special aesthetic preference or temporal preference or sentiment preference as part of your account, not only your face, this can become more secure. Once again, social behavioral biometric flow chart. When we, let's say, use Twitter data and timeline for the corresponding user ID, we identify the tweets as a text, we identify replies, retweets, and mentions. We can also add the next level of complexity, such as trust for the friends, trust to the website, trust for the retweets, trust for the hyperlink that you provide. Similarly to the Google search that use huge live information data set where the trustworthiness and number of hits and popularity of the website decided mainly by the user collectively. Then in a similar manner right here for the tweets, we can collectively establish the trust within a given user or trust for the given tweet or trust for the given website that's been tweeted. Then we can use personality traits classification, user recognition system, graph representation of user social network. All of those will be used to create a template of the user, perform similarity-based match or top-end match, and users' IDs will be reported when the next sample comes. So essentially, it's enough for us to have very short tweet, one line to run this whole machinery and to say whether this line belongs to known user or not. Yes, this is a great question. So I'll get to that question right now. So yes and no. So I will answer the second question because we'll get to deepfake first. And I will actually, maybe if you guys send me more questions, I can actually focus more on interactive conversation instead of going through my slides. Even so, I'm done pretty much more than 60% of them. So as researchers, what we do, we create know-how. All the information that we write about, let's say, behavioral authentication of the users using their Twitter information or algorithms that we use to combine Wikipedia account and disambiguate accounts that belong to the same person but created under different aliases. All of this is in the public domain. We present this information at the top cybersecurity conferences in the world, in New York, Fordham University, Purdue University Cybersecurity Center, at Microsoft Research. And as we present, there's a large number of companies, police officers, FBI agents, as well as foreign actors, actually, that are having open access to this information. What done after with this information is we cannot trace or track, but I can tell that, for instance, Canada, what I can tell definitely that Canada Defense and Security, we had a 5-year contract with them, and they essentially were, at least in their research, they were utilizing this model that we created for identifying social media users to perform their online observation of the activity by foreign actors, again, potentially Canadian interests. So this has been used within the research organizations and defense in Canada directly, in other countries indirectly, from our open access model that we publish. So essentially, we don't sell them directly to the companies, but we have a government contract to deliver services or software to them. Online avatars. Yes, exactly. Absolutely. The second question is exactly what I was saying. We did the research. It was a great place in Hawaii, and there is a Hawaii University, as well as Center for Visual Computing Research in States. And we worked with the company, and the company created avatars, created online, large online game design. I forgot the name of the top of my head, but I had it on this slide. So I'll actually look it up right now very, very quickly. Avatar Reality. So Avatar Reality USA was a company that we collaborated with. And essentially, we integrated our kind of monitoring of avatar activity framework to create templates for given avatars. There is a news story. We did also research on this with Professor Roman Yampolsky from University of Louisville in States. And I'll have this picture at the very end of the slides. But essentially, the news article story saying, is it the same cyclops that you saw yesterday? So we actually used and incorporated our methods to saying if behavior of certain avatar is the same as it should be or not, based on our online behavioral profile, and integrated it to tell if the same human person, right, is the same actor, human person is running the same avatar. What's more interesting actually is the concept of interreality, and interreality is actually the concept that kind of got quiet over past 10 years, but I bet you it will become very, very popular with a new infusion of AI into development of actually virtual actors. As you know, in video games and virtual games, you can have avatars driven by humans, or you can have bots or entities that are just entities created by game developers. And that's where all the fun begins, because it's very hard to tell sometimes whether you're communicating right in the game or chatting with a real person, or you're chatting with AI. As you know, Turing test was bypassed by computers way, way back. So it's a test when we have 5 experts sitting behind the screen and they talk to different computer software that can imitate human language. And if more than 3 experts believe that they talk to the human, then bingo, the software passed the test, right? So that was done, I think it's already 1998. Some of the large language models, systems, and software could beat this test. ChatGPT does it with its eyes closed, right? And it's like easy. ChatGPT 4 and the next versions can do it easily. So the question will become is next time you play the game, do you know if you're playing against a real human? Do you know if you're playing against ChatGPT powered or some other AI powered inter-reality actor? So this is quite interesting. Anyway, I actually will get through, and I still see the very first question about deepfakes that I haven't answered yet. But just to summarize it and being mindful of time, this is an example of what we do, and I probably will skip the boring part about architectures. On the left, you have a person set of favorite images. Maybe they're on the, on your desktop. Maybe they're on the office wall. Maybe it's in a Flickr ID. And exactly. Yeah, exactly. Yeah, that's a good point about avatars. But you have to think about it because that's what's going to be happening very, very soon. Especially if you communicate behind the screen, you wouldn't know. Anyway, and so is it possible to predict identity or gender? So this is pretty cool, and I would focus on this example because it just tells us so much about human identity just by the picture that you like. When was this question, nobody else in the world has this question, by the picture that you like, and you tell what's your gender. And here I mean gender in the biological sense, at birth, given at birth, male, female, or if we do the basic ground truth, we can also ask users, and we did ask users about how they identify currently. Within just the two very fixed categories, there's way more, of course. And we were the first also to answer this question in the lab, saying that yes, and we can identify it and predict the gender just by the picture that you like with accuracy of 80-90%, based on the very interesting features that images have. And those features are symmetry, colors, textures, color combination, sharpness, strength of the edges, and a whole bunch of other features that AI and ChatGPT will extract, but we human wouldn't understand, like first, second, third derivatives of the textures. Anyway, I'm going to skip through this because this is just what we do with that research. Here is an example of the favorite images for user 15. You can see it's kind of more soft and blurred on the left. For user 19, it's more sharp. And from those images, a very important point right here, and very quick one. We did this research first about 10 years ago, and we identified handcrafted features by using classical machine learning. Here's a whole bunch of those features: standard deviation of S channel and HSV color image, for instance, and entropy of RGB and image, correlation and energy and homogeneity and contrast within some other framework, symmetry, also emotion-based features, pleasure, arousal, dominance. Very, very important to identify human gender as well as identity. And those features not unique to images, by the way. You can expand all of those features to the way we talk or communicate online, right? We talked about social communication, how we talk to avatars. Once again, some of those features can directly be used as the features to identify if you're talking to the bots, the robot, the avatar, or the different person. Anyway, moving on, we created this architecture. We used we used evolutionary computing in this particular case to perform training. We got 94% accuracy in identifying the person and the gender based on our features. By the way, when the very first research was done, it shows accuracy of 14%. It's kind of a little bit weird to think about it because the random flip of the coin gives you 50%. So that's actually worse than random. I don't know how they managed to achieve it. But to give them credit, this group, they were the first to collect this data set and start this whole research. And then when we rerun it with new deep learning framework with classical domain features, we spent about a year to develop the system with new deep learning framework, was just basic CNN, image processing, residual learning based CNN model, ResNet, I believe we used. I don't remember which one, 34 or 44. And took us about 2 weeks to program, another 2 weeks to run the algorithms. And we got 98% accuracy. In rank one means the first person being identified correctly for identity. Rank 5, 95%, which is almost 100%, which means that we actually get all the people who could potentially like those images out of large data set within top 5. and then rank 1 is the top. The correct person was identified in 97.73% correctly. And we can also identify the gender with almost the same accuracy. So that's pretty impressive, first of all, of what deep learning can do. And second is, just how many features are there in just the basic image that we don't think of as human, or in the text as well. We did the research saying essentially from the text we can identify psychological profiles of the person based on Myers-Briggs, for instance, criterion classification. And once again, the same set of we can identify depression. We can identify emotions on various emotional scales of the person just from the sample of the writing. All right, now, well, let's get to the first question. With implementation of deepfakes, are there concerns of face biometric being bypassed? Absolutely. So countermeasures, if we talk about biometrics, live detection, so essentially video liveness detection, in-person liveness detection, anything that can measure pulse, temperature of the body, or can test if the person in front of you is true, real. With a very, very good deep fakes that can generate, let's say, my video right now of me speaking, using my voice, my manner of speech, my vocabulary, my appearance. Very soon it will be very hard to do, right? Modern biometric devices were not built to counter deepfakes from behind the screen. Remotely, very difficult. In person, possible. Bigger issues, for instance, another example of some of the companies that wanted to, yes, exactly. No, one never wins. I agree, Arthematrix. One would never win because it's going to be as 1960s as Sirius is the biggest center for cybersecurity was created. It was created 40 years ago, and they say in about 10 years we will create networks that will be non-penetrable. We will create the fire walls that will never be broken. We will make sure that we have multiple layers of security and protection on multiple for all the assets within organizations that never will be broken. And what happens now is just information presented in a public forum. If there are centers for attacking governments, organizations, hospitals, facilities that build planes, airports, these large centers that operate illegally, obviously, and run on dark web, they employ thousands of experts on how to breach all of those best firewalls in the world. Like, this is ongoing battle, and people actually switch from one side to each other very frequently. I talked to a person who was working on creating software to break into the companies, and after 20 years became one of the top Canadian professionals to prevent attacks and independent consultant to help companies to protect them. It's the same with AI. Pretty sure about it. But it's fascinating to hear their stories. This image I did show in a couple of my presentations. I can ask you guys now as just a kind of closing part for my lecture, because I do believe we have 1 hour. If I'm wrong and if we have 15 more minutes, please do let me know. But you can just actually came up with the image of pretty good quality, and you can guess what's wrong with this image. Potentially, yeah, go ahead. Let me look at the private chat. It says I have more time. Yay, bingo, excellent. So anyway, I'll still want to wrap up main core presentation soon enough. But let me ask you right now, guys. What do you think? You can type in the chat, on a private chat. What do you feel like could be wrong with this image? And obviously, we're talking about AI generated stuff, so you can kind of allude to the image probably somehow modified or not really truly true image. But what innocent strikes you as you look at it? There are quite a few hints here in the image. I'll pause right now. I know some of you there. I'll take a sip of tea and wait. Yep. Well, anybody else? Yeah, that's a good point. Wonderful coordinator, Kimi. Anybody? I don't see you guys. I should have maybe somehow seen everybody here, but anybody else? Any other ideas? It is kind of grainy and low quality. Yeah, you can look at the umbrellas, shadows, clouds, reflections. Exactly. All right, so that's enough pretty much. So essentially, umbrellas are up, doesn't look like it's raining. There's no drops on the ground. Also, you can see it's very, very strong overcast, but you have very prominent shadows, which is extremely weird. And then in the middle on the left, there's none. Then if you look at the kind of at the back where the umbrellas stand on the middle right side of the image, there's something going on with umbrella being both in front and behind the stand. By the way, just as an interesting fact, just because I always bring up what's happening now, as you know, in the UK, there is a law that no newspaper can publish digitally modified image. And the big news this week is Kate Middleton, the wife of Prince Williams, has actually published very recently digitally modified images. So they were just created using the basic software, and there's a big scandal because the newspapers pulling those images out. So this image also would be pulled out from English newspapers, because the correct answer is yes. It's here's the story. The story is actually fascinating. And I think on this story, I will actually finish my presentation and then we can chat. So Wales is a provincial North Macedonian town, 40,000 people, which placed itself on the world map in 2016 as epicenter for fake news production. So as Wales fake news articles spread to millions of people via Facebook, Twitter, and other social media sources, many of those news hackers made substantial sum of money. So that was also done through the dark web operation, and it's essentially the orchestrated misinformation campaign that was supposed to help some of the candidates during the US election. As you know, US election are coming back again. Joe Biden against Donald Trump. So we will see the same thing unfolding very, very soon. So Jonas Bendingson is a photojournalist and a documentarist. And he traveled to this place, the Wales, to explore this unlikely hub of misinformation to find out what happened there. And then what he did, he created a wonderful book, this Book of Wales. The book was sent then to European agencies for a competition. And it won. I don't remember which award it won, but it has won one of the top awards for one of the best documentaries about fake news production in 2016. And about 6 months after, as far as the story goes, give or take, Jonas Bendingson put an opening statement on his website with the book, which sells very well, and the award saying, hey, the whole book is faked. It was digitally generated. So every single image in this book, and one that I showed you, was AI-generated images. It was done using ChatGPT 2, so predecessor of common ChatGPT. Imagine what the modern AI can do now. And it was used to create text caption stories for this book, text name of the book, as well as also it's put all the humans in the places. So every single place and space that he photographed was true. He found some factories in this town of Wales. He found some empty streets. He found some parks. They were completely empty. Every single human, and correspondingly all the umbrellas and all the artifacts that belong to humans, all the shades that belong to humans, were artificially generated. So all of you were right who guessed. And essentially, it became a fake news story about fake news story producers. Nobody figured out back then in 2016-17, and absolutely nobody would figure it out now if another book like that would be to publish. And the message of the story is we really have to be able to trust what we see. And there is not much in this world left to be trusted or trustworthy in terms of the images. When we think about newspapers, the most reputable newspapers, right? New York Times or TV shows in Canada, news station CBC News, CBC Radio News, they would rely on eyewitnesses and the testimonies of videographers like John Bendixson to go there and document what's happening, right, with their physical cameras and taking the photograph from the place, giving the interview from the place. With deepfake, that can be faked. With deepfake, the images, digital images can be generated. Artificial becomes harder and harder to tell whether they're true or not. One of very, very famous historians, Yuval Harari. He's an Israeli scientist, researcher, political scientist, and author of a couple of best-selling books. On the most famous one is called 21 Lessons from 21st Century and Sapiens, the history of humanoids or history of humans. So when I listened to his lecture live on Geneva UN forum on emerging issues remotely over Zoom last year. And at the end of his quite fascinating, very well put together presentation, he said, how do you know if this is me who wrote this text or AI wrote this text? You will never find out. And I think that's something to keep in mind. It's pretty strong. So he said, are you sure it's a message that I want to give? Or maybe that's a message that AI want to give. And of course, there's a huge debate about AI becoming sentient, being sentient in the way they all communicate and connect to people, but that's the whole other can of worms. I will skip, it's 1 hour right now, so I will skip through those slides. But this one is fascinating. This is Professor Nadia Talman. She was here in Calgary visiting a conference, CGI. She's one of the founders of this conference, as well as founder for the Singapore Center for Creating Robots. So what she did, she created one-of-a-kind, single in the world, robotic representation of herself. You can see her robot on the left. You can see her on the right. The robot has remarkable ability to access internet, chat and express itself in the human language, has expression modeling, has gesture modeling, can engage in the conversation about you, your children, the weather, and will remember you for the next time. So that's pretty cool. And of course, right now with robotics, we will have the whole, I mean, you have seen the YouTube videos of way more modern, way more scary robots that can walk, talk, and interact and do household duties and communicate with people in real life setting. And it's extremely exciting, but it's also quite scary because with AI and deep learning, the biggest issues right now, you heard it probably 1,000 times, millions of times. It's a black box technology. We don't know how it learns. We don't know what it learns. We definitely don't know the thought process that it goes through. We can train it, design it. We do it in our lab. We deconstruct all the different architectures, out-encoder generative AI, CNN-based LSTMs, GANs. And when we deconstruct and put the blocks, we can infuse some of the let's say, personalized information in the architecture to steer the learning towards certain connections or certain factors that we use domain knowledge. So we call this hybrid domain knowledge, highly customizable architectures, but we still cannot control what happens in all the other layers of the network. So that becomes the biggest issues of how we as human will coexist with those powerful systems that can process information million times faster than human can, store information, and they never get tired of the jobs they do. Unlike humans, they don't need to eat, they don't need to sleep, and they can continue and do anything that they set to do. I will skip those slides on the identification. This is pretty much just information about how we can create information. So essentially how I can make my face, how I can modify my image before I put it on the website or on the video, so that it's not becoming the source for the deepfake, but it's for a different time. And ethics and privacy consideration here is exactly what we were talking about. So algorithmic bias is an inclination of the system to make decisions favor one group of users or individuals based on flawed principles that in general considered to be unfair. And essentially there's a whole bunch of issues with privacy, security, ethics, data bias, algorithmic bias, and fairness that might be considered when we develop deep learning algorithms or classical machine learning, because we don't want to make mistake when we identify person or make decision about somebody hiring somebody or making decision about loan application, etc., etc. This is very, very complex, and the ways to predict and mitigate it, identify, explain, and mitigate different mitigation strategies, proper data collection, cleaning the data, removing protected variables, age, race, gender, introducing proxy variables, place of birth, graduation year, school name, adding documentation about how data was collected, user training compliant, using multiple experts as multimodal systems is one of the ways, and using commercial available toolkits such as Microsoft Fairlearn, for instance, to mitigate this bias. I've actually gone through everything that I wanted to say. In summary, there are quite a few open problems and challenges. Big data analytics and data learning provide new challenges to society just by the sheer amount of information that's been generated. They definitely possess significant privacy risks. Anybody who's working with any type of biometric identification, cybersecurity, content generation, or verification of the authenticity should be aware of explainability, ethics, bias, and trust in the model. Real-time analytics powered by AI from video, sound, and social communication becomes very important, identifying fakes as well. And obviously, AI singularity, sentience, and generative AI present even more open questions. And in the last 2 years, almost any conference I've been to, and I've been invited to a large number of panels in various places like Stanford, Berkeley, Oxford, Southampton University, University of Bournemouth, which in UK, which has the largest center for computer animation. All of those top places talk about generative AI and awareness, creating awareness of all of those issues when we use them for research. And here is just a couple of, for fun, information to contact us, our website. The first one is BBC News 2011, virtual people get the ID chat, or is it the same Cyclops that you have seen yesterday? Some of those interviews go back to identifying avatars versus human actors in virtual reality and games. Then Discovery Channel Canada Science seriously created fake fingerprints in our lab at the University of Calgary, and it's here just slightly younger than now. 10 years ago was Jay Ingram. And then we had exhibit at National Museum of Civilization on power of biometrics, where we actually created my avatars that could talk to people and ask about their fingerprints and ask about their trust in technology and if they know about identification. And then forthcoming University of BI cybersecurity interview on social biometric online security that was then went on to discussion with some of the agents on utilizing it for commercial and proprietary, very proprietary applications. I have completed my content delivery. That's all I wanted to say right now. And if you have any more questions, I will be happy to stay a little bit longer and chat with you. Thank you for your attention.
Thank you so much, Dr. Gavrilova, for all that. It was beautiful. I did have a small question. Something about the image where you want us to see like what's wrong with it. It was like with the umbrellas and like the reflection.
Yeah.
If you go back that real quick, please. You mentioned something about
here. Yeah.
Yeah, you mentioned something about the umbrella on the right side. I didn't really understand what you meant.
That's
by that
not
being
important,
standing
but
out?
it just standing right there. That seems to be some artifacts with these images of umbrellas and the human at the background with the posts that are generated there. Or there's umbrellas. There's no let's say no shade from the umbrella, but there are shades from the human walking, and those there's just a large number of. Come on, it was ChatGPT 2, so it didn't do a good job yet.
Okay, cool.
Right
That was
now with with much more modern technology. So that was done 2016, right? So right now, almost 8 years after, the image will be like, we would not be able to find any of these artifacts with the human eyes.
I see. Okay, that was cool. We do have one question here.
Yes, of course.
What sort of ethical guidelines need to be met before publishing research on advanced AI? Are
Right.
there any laws, etc.?
Yes. So right now they actually been developed. The Canada came up with the guidelines for developing AI in a trustworthy and ethical measure. It's on the Canada government website under category research on AI. The European Union and Geneva Convention produced report. I actually contributed to this report because AskMe is one of the Canadian experts to provide my feedback, and they had like 20 questions saying, what is the potential risk of using AI unchecked? How would you integrate it in student education? Would you generate your course content versus using ChatGPT and AI? What kind of awareness should company have when they use artificial intelligence tool to, let's say, decide on, I brought this example many times, to decide to give the loan or not to give the loan to the person. And so the whole bunch of these questions, the report was generated, sent to Geneva Convention, and is put in front of European Union to adopt it into actionable procedures. So right now, what we do within this university, even we have, as you probably know, created transdisciplinary institute. Within this institute, we have number of research chairs. And once again, I was very lucky. I received the research chair in Trustworthy and Explainable AI for the whole university. And within this framework, we talk about ethics, new ethics courses. The institute will offer a transdisciplinary program, let's say, in departments of computer science and art, looking at the ethical use of AI, looking at plagiarism and AI, for instance, in education, looking at whether there should be some rules for incorporating AI when you put it in mechanical engineering device and machinery. The fun example, a great question, by the way. And so the answer is the laws are coming in, the regulations from European Union coming in. The Canada just put on the set of directives within the AI research on AI, ethics, and privacy. And just a fun example that I think I told it to some of the presentations, but not to you guys. It's already kind of old, but it was about a year ago. There was a lawsuit in America that, as you know, very famous for lawsuits. One of the passengers of their company was suing the carrier for not bringing their luggage on time, and there was some complications. So there was a group of lawyers. They presented beautiful case. It was amazingly written. It was well presented. They brought it to the court, and the lawyer by their company very quickly discovered that the whole lawsuit was written using ChatGPT 4, and it had incorrect references. So essentially, it was referring to, as you know, in case, let's say, Warden against Trevor 2012, there was this precedent. So the case didn't exist. So the whole lawsuit was thrown out of the court because the lawyers, non-experienced lawyers, used ChatGPT without checking references. So advice to you: always check references, always verify what you see is, as we discussed, right? You cannot trust the image, you cannot trust the video deepfake, and you cannot trust what ChatGPT creates. It has this wonderful, I heard this on one of the recent conference. it's almost a term, either it's dreaming or it's delusional. So it's kind of gets in a dreaming state in which AI in the dreaming state generates those citations that don't exist in the real world. And detecting those states is what researchers do.
Okay, awesome. I don't believe there's any more questions.
Doesn't look like it.
So I think from there we can wrap it up. Thank you once again, Dr. Gavrilova, for a wonderful presentation. It was very insightful, really fun and interactive. And thank you to everyone who tuned in tonight for the for our speaker series.
Absolutely.
Yeah. Have a great day, everyone.
Good luck with everything, guys. Yeah.